Hi everybody. In this video, I am going to be showing you how to do multi-step conversions. Up here on the right-hand side of the page, I have our three options for equivalence ratios. And these are the only options that we have to put into conversion factors. So in this first problem, it says how many grams, remember grams is a G, of carbon dioxide are in 6.35 liters of carbon dioxide. So we start off by writing our given. So we have 6.35 liters of CO2. And we build our conversion factor. Remember, you always put the unit that you start with into the denominator of the conversion factor. So we put liters of CO2 down here. Now, our equivalence ratio, if we take a look up here, our equivalence ratio with liters is that 22.4 liters is equal to 1 mole. So we're going to fill that in. We have 22.4 liters is equal to 1 mole of CO2. We're able to cross off liters because one's in the numerator, one's in the denominator, and we're left with moles. But the question asks for grams. This is how we know that we must have an extra step. So right now we're in moles and we want to cross that off. So we build a conversion factor and we write moles of CO2 in the bottom. And we know that the molar mass of something is equal to 1 mole of that something. So that's our next conversion factor. So 1 mole equals the molar mass of CO2. When we calculate the molar mass of CO2, carbon equals 12.01, and there's only one of them. Oxygen, there are two of them, and they each have a mass of 16, so that's 32. So 32 plus 12.01 is 44.01 grams per mole, which is why we have the mole down here. So 44.01 grams per mole. Our moles are able to cross off because we have one in the top and the bottom. We're left with grams, which is exactly what the question asks for. So at this point, we are ready to solve. So remember, you multiply anything in the numerator, you divide by the denominator. So as I plug this in my calculator, I'll say it out loud. We have 6.35 times 1 divided by 22.4 times 44.01 and then divided by 1, but it's going to be itself. And the answer I got was 12.476. There are three significant figures. So 12.476, that will become 12.5, and the unit is grams of CO2. Now in the next problem, it's asking for molecules. So how many molecules of nitrogen dioxide are in 43.6 grams of nitrogen dioxide. So for this one, because we are using grams, we do have to know what nitrogen dioxide is. Nitrogen dioxide, remember, if the first element in the compound does not have a prefix, but the compound is made of two nonmetals, then the first element, there's only one present. Now di is a prefix of 2, so this is NO2. It's involving grams, so we do know that we're going to need to find the molar mass of this at some point. So you can either do this first or you can do it second. It's up to you. So we first start off by writing our given. So we have 43.6 grams of nitrogen dioxide, which is NO2. build your conversion factor. And I'm going to do this one a little bit different. I'm going to plug all my units in and then go back and plug my numbers in. So if we build our conversion factor, we want to set it up so that we can cross off this grams. So we put grams of NO2 in the bottom. Now if you take a look at the options for equivalence ratios, if we find grams, grams is equivalent to 1 mole of the same substance. So the thing that goes on the other side is 1 mole of NO2. Grams can cross off. We're left with moles of NO2. But we don't want moles. The question is asking for molecules. So we have to use our 6.022 number. We got to set it up so that things can cross off though. Because we're left with moles in the top and we don't want moles, we want molecules. We want to be able to cross this moles off, so we have to put moles in the denominator. So we put moles of NO2 down here. And then the question is asking for molecules, so we put molecules. We'll do molec, so it doesn't look like moles. Molecules of NO2 up top. Now we're able to cross off moles and we're left with molecules. But the thing is that we have to fill in our other numbers. So let's take a look here. So we have grams written down. And so remember, we get our molar mass by adding up the mass of all the elements in a compound. So here we have 1 nitrogen. Nitrogen's mass is 14.01. And we have 2 oxygens. So 2 times each oxygen is 16. So that equals 32. So 32 plus 14.01 is 46.01. So we have 46.01, which goes next to the unit grams in our molar mass conversion factor. And then over here, we have the unit mole and the unit molecule. So if you look back to our equivalence ratios, wherever we see the unit molecule, that's the equivalence ratio we use. So here we have 1 mole is equal to 6.022 times 10 to the 23rd molecules. So that's what we put into this conversion factor. So we put 1 next to mole and then 6.022 times 10 to the 23rd molecules. So when we calculate this out, it's very similar to the one above where we divide then multiply. But we have 43.6 times 1 divided by 46.01 times 6.022 E23. Now, because we're going to molecules, we should get a massive number. So if your conversion, if you end where you're converting to molecules, ions, atom, you should get a very big number that has an exponent. And that's kind of how you can check your answers with those as well. You should always expect something with a times 10 if you're ever going to, if you're using Avogadro's number last, basically. So in my calculator, the answer I got was 5.70658, and there are three significant figures. So that leaves us with the answer of 5.7, and there's an O and then a 6. So that 6 is going to round that 0 up to a 1, and then it's times 10 to the 23rd. And the unit is molecules of NO2. That is how you do a multi-step conversion. Basically, whenever you don't go to or from moles, you must go through moles. So you have to have this multi-step where you first go to moles and then you go from moles to the desired unit. Do not ever combine these two steps. So I hope you're understanding this, and I hope you have a wonderful day, and you can work on practice on the next couple pages with these multi-step conversions.